Folks, this is to give you a recording notice. This lecture is being recorded. If you have any concerns, you need to contact me, please. Today we are going to start a new topic, which is Monte Carlo simulation. Monte Carlo simulation. Now, before jumping into the definition of Monte Carlo simulation, I would just like to explain you how do you define the simulation itself. Is a technique to perform an experiment on an imitation of a real world system. In order to obtain data that can be used to make predictions about the system. This is your definition of the simulation. A statistical model is one that takes random samples from some probability distribution that describes the operation of some aspects of a system or the total system. Folks, I need to go to the next slide, please. Simulations that involve random sampling are called Monte Carlo simulations. Simulations that involve random sampling are called Monte Carlo simulations. The Monte Carlo simulation, or it is based on generating multiple trials to determine this is D here, properties It could be such as expected value or the mean value, or standard deviation, etc. of a random variable. So we generate multiple trials and we determine the different properties of a random variable. For large size of samples and complex models, complex we use computer tools. This computer tool is the Microsoft Excel, such as Microsoft Excel. Now, in case of using Microsoft Excel, the multiple trials are generated by propagating a basic formula as many times as the number as many times as the number of, folks, and to the next slide, please. Number of iterations. In Monte Carlo simulation, this is what we called as the number of simulations. Number of simulations. I have one example for you, and I will explain you all these terms in that example. Required by the model. Now, there are some steps that you need to follow in Monte Carlo simulation. It involves, the first step is repetitive generation of artificial histories of several time periods during which the system is operating. The second step, doing a statistical analysis of data collected. The third and the last step is drawing in about real model system. Folks, I need to go to next slide, please. As I mentioned, we can use Microsoft Excel to perform Monte Carlo simulation, and we also discuss probability distributions. So I'm going to write down some formulas for the most commonly used distribution in Microsoft Excel. Most commonly used distribution in Excel. So we will look on the some probability distribution that we use in the Excel. Now I was discussing about developing some random number of. So the formula that we use in Excel to develop a random number is the R, A, and D. That's what is used in Excel. This is a function that generates random numbers in the interval 0 and 1. So that means when you will use this function in Microsoft Excel, it is going to give you a number which will be between 0 and 1. Now first we write down the distribution for uniform distribution. Uniform distribution. If u of I where your I value is from 1, 2, 3 up to n is uniformly, if ui is uniformly distributed random number to find the corresponding number if ui is a uniformly distributed random number, to find the corresponding number xi, switch the uniform distribution in the desired interval of A and B. Now, if you recall from the uniform distribution, these were the maximum and minimum values. Folks, I need to go to the next slide, please. Now, by this statement, I mean to say your x of I, that will be equals to your uniform distribution with the parameters of A, and the CDF of this uniform distribution was f of x which was integral from minus infinity to x of I into f of x of I into d of x. And for two intervals a and b, it was from a to x. This is 1 over b minus a into d of x. That is equal to ui. Now, if I wish to find out my ui from this equation and you solve them, you will get u of I equals to x minus a over b minus a. And I'm interested to find out the value of my x here, which will to be u of I into b minus 1 plus a. So this is what is giving you the formula to write down in your Excel. Now just note down one more thing. Your x of I is equals to the f inverse of u of I. Now by that I mean to say, if I want to write down the uniform distribution in x, I will write it down the minimum value. So it will be min in Excel plus, Now this UI is your random number here. So for the random number, my function is R, A, N, D. And then your B is the maximum minus your A, which is your minimum value. So that's what you are going to use for your uniform distribution. Now in case of exponential, your x of I is equals to minus 1 lambda value natural log of 1 minus random number R, A, T. So that's the formula for your exponential distribution if you are using the exponential distribution in your Monte Carlo simulation. And this formula is for your normal distribution. Folks, I need to go to next slide, please. Oh, sorry, uniform distribution, I mean to say. Now, if you have normal distribution, for normal distribution, the formula should be NORM dot I N V your random number, which is RAND, comma the mean value, comma standard deviation. That's what is a formula for normal distribution. Standard deviation. Now, in case your variable is following the Poisson distribution, we have Poisson, POISSON dot DIST of random number. So it should be RAND and your mean value. And then it could be true or false. It could be true or false here. For the cumulative function CDF, we use true value. And for the PDF, we use our forms here. Now, another distribution could be the log normal distribution. For the log normal distribution, our formula is LOGNORM dot INV RAND the mean value and standard deviation value. Standard deviation value. I need to go to the next slide, please. Now, once you have performed your simulation, what you will do in the analysis part. So in the analysis, you can find your mean value, which is using the formula of average. And just choose your range. You can also find out the median by using the formula of median. Now, because we are going to write them into the Excel, I will just write down equal sign here because these are the formulas. You can also find out your minimum value using the function of min and just provide the range. You can find out the maximum value. So it will be max of your range. You can find out standard deviation. For that one, you will use STDE V dot S of range of your data. You can also analyze your simulation to find out either you have positive skewed curve or the negative. So if your mean value is greater than your median, That's what we have learned before. It will be a positive skewed. And if median is greater than mean, it will be a negative skewed curve. Now you can also find out the percentile. Percentile. So for that one, your function should be PER CEN TILE dot EXC. Then you provide the range of your data. And then you input your percentile to calculate. For example, it could be percent or 95 percentile. Now I'm going to take one example and I will show you how you do this in the Microsoft Excel. Folks, I need to go to the next slide, please. Now let's do one example here. Consider a hypothetical and a model for ammonia. What is our model here? Y is equals to x1 square over 3x1 plus x2 power 3 by 2, whereas y is your process temperature, your x1 is the thickness of the reactor wall, thickness of the reactor it follows uniform distribution with maximum thickness of 10 inches and minimum thickness of 4 inches. And x2 in this model is the radiation heat transfer rate. This variable x2, it follows normal distribution, normal distribution with the mean of 1000 kilojoule per second, and deviation is defined as 50. Folks, I need to go to this. Now, what is our objective here? We need to find if the Y is the process temperature is positive skewed or negative skewed. Also find 75 percentile using 10 simulation. Now I will take you to the Excel and I will perform this Monte Carlo simulation over there. First thing, I need to mention something about the random number. So we want to generate a random number, and as I mentioned, the formula for this is, because we are writing a formula in the Excel, it should start with the equal sign, and you just type in R, A, and D and click it. This is the random number. Now this is called the random number. It should be between 0 and 1. This is the random number because time I press F9 on my keyboard, this number will be changing. So right now I'm pressing on my keyboard. As you can see, this number is changing all the time. Or if you enter anything in any cell and hit enter, it will change it. The number is changing now. Now let's come to our numerical theorem. First, you need to write down the given information. So in the given information, we have x1 is uniformly distributed with maximum value of 10 and minimum value of 4. That's what is the given information for our x1. The second is x2. x2 is normal distribution variable with mean value of 1000 and standard deviation of 50. Now, as a very first step, we need to perform first simulation, and then we can expand that to 10 number of simulations. So here at this column, I will write down the number of simulations. And for example, one simulation here. Now, if you look at your model was something like this. Y is equals to x1. It comes in the power of 2 divided by 3 times of x1 plus x2 power 3 by 2. That's what our model is. Now, once you have the column for the number of the simulation, the next column should be generating a random number. So I will write down here random number. So random number generated through RAND and hit enter. This has generated a random number for me for my first simulation. In the next column, I will look at my model. Now the variable is the x1. Now, if you look on your statement, x1 is that should be uniformly. x1 is the uniformly distributed. x1 is uniformly distributed. So for uniform distribution, the formula that we have is minimum value, start with the equal sign here, and the minimum value is 4 for x1 plus the random number. Because we have all here, I will just choose this random number here, and that should be multiplied by your maximum value, which is 10, minus your minimum value, which is 4 here, and I hit, so I get a number here. Again, if I press my F9 here, this number will change. Even x1 number will change because it has the random number involved in it. So I'm just pressing F9 at the moment. Now let's come to x2 here. The x2 is a normal distribution. This is the distribution. X2 is the normal distribution with the mean of 1000 and standard deviation of 50. So for X2, I will start with the formula of NORM dot INV. Now it is asking me the probability value, which is your random number here. So this is my random number. And then I need to provide the mean value, which is 1000. And then the standard deviation, which is, and I hit enter. This again give me a X2. Now again, I press F9 on my keyboard. This number is changing. I'm just pressing F9 on my keyboard. On this one, the last one, we can find out our Y. So for the Y, this should be X1 square. So it should be the square of this number divided by 3 times of X1, again this cell, plus X2 power 3 by 2. I hope I'm not making any mistake here. So this is what is your Y value here. He was asking us for 10 simulations. So what I will do here, I will just write down 1, 2, 3, and I can drag it up to my required number of the simulation, which in the given case 10. Now considering all of this, all of these should be dragged down to 10 simulations. Either I can do them individually, or I can just select them all and drag them to the 10 simulations. This is a column for your Y here. We need the analysis on this Y now. The first thing is we need to find out either it is positive skewed or negative skewed. For that one, I need to have the mean and the median. So for the median, I know that the formula is the average here. Now it is asking me the range here. I'm starting from this number and up to the last number of my simulation, which is at number 10 simulation. Mean value here. This is my mean value. Now let's find out the median here. The median should be equals to MEDIAN. And again, the same range should be there. And I hit enter here. Now, as you can see that your median is greater than your mean. So this means it is a negatively skewed curve. So this curve is negatively skewed. There are some changes here. Our median is changing now, which is less than the mean. I will come to this point, just give me some time. So for example, I go with the very first result. Our median is greater than mean, which is a negatively skewed curve here. Now the next objective was to find out the percentile. in terms of finding the percentile, we have PER, C, and percentile dot EXC of the range from this to this, and then I need to provide the percentile to calculate the range, which is 75 or 0.75. That's what is your percentile value. What does this 75 percentile shows? That we are 75% sure that process temperature will be below this value, or we are 25% sure that the process temperature will be higher than this value. This is how you interpret your percentile results. One thing you have noticed here, whenever I am changing any number, the values are changing with the change of the random number, even though our results was changing. Now, what is the solution here? We call this as unstable results in Monte Carlo simulation. So once you are performing your simulation, your results should be stable. Your results should be by that I mean to say there should be no change in our results even if we change our values or the random numbers. How do you attain this stability in Monte Carlo simulation? You attain this stability in Monte Carlo simulation by increasing the number of simulations. If you have 10,000 simulations performed, this is where you get the stable results. Now, performing simulation here, you just drag it down up to 10,000 point, the number of simulation, and then you drag the random numbers, or you will drag your x1, x2, and the y. If your model is too complex, you will have too many things that you need to make up to 10,000. So what is the solution for this thing? The solution for this is we can use some softwares. There are two very famous software. One is called as At Risk. If you are on campus at the moment in engineering building in the lab EN3000, you will find this software. There is a full version of this software installed in that lab. This is in engineering building. If you wish to use it, just make sure you contact the CEP and ask them if it is safe for you to come to the campus or not. Now, the second software that you can use for these much number of trials is the crystal ball. Both of these softwares, they're free. The trial version is free and you can install it at your home and use them. I had a pre-term lecture on how you can use the crystal ball that I will share on the D12 for your knowledge and practice. There is a example there. One is solved in the Microsoft Excel and other is solved in the crystal. Try to work on those examples and those will help you. Folks, I will stop it here and I will take your questions if you have any. Folks, do you have any questions for me? Asking, I cannot understand the purpose of pressing F9 key. The purpose that why I explain you this is that the random numbers will be changing all the time if you make any changes in your sheet. By that I mean to say, if you are performing one solution of the question, for the same question, your friend will have the different random number. So you don't get confused. So that's why I pressed F9 and showed you that your random number will always be changing. Okay, Don is asking, do you know how long the trial software lasts, time or the number of the uses? I believe it is for 2 weeks. John, I believe it is 2 weeks. You can have the crystal ball and at-risk software for 2 weeks. You can use them with all the features that you need for your studies. Okay, Yakuba is asking, please let us the computation of x1. Sorry, what did you mean by that? I think you're asking how I did x1 computation, right? Okay, I can repeat that. Before I go to sheet, let's look at the x1. x1 is the thickness of the rectus wall. It follows the uniform distribution. And I do have the maximum value, which is, and the minimum value of 4. So what I did here, the formula that I set up, which I wrote it down in the previous slides, it was the minimum value plus random number times the difference of maximum and the minimum values. So this is what I am doing here. I have my minimum value plus random variable which I generated in cell C8 multiplied by the difference between the maximum value, which is 10, and the minimum value, and then I hit enter. So this is how I develop my x1 values. And because I need it for 10 simulation, I can drag them down to 10. Is that clear? Okay. Usman is asking, there are 2 types of the percentile. I mentioned you the formula, what type of the percentile. It will be .exe. Just look at your previous slides in the lecture of today. You will see the formula there. Usman? Now, exe, the difference between them is one includes your percentile value, other one includes your percentile values. You need to use the .exe here in these calculations. By that I mean to say, if I am doing 0.75, so it will, if I use INC, it will include that number. If I use .exe, it will exclude that number itself. It does not matter how much complex is your model. The only thing you need to know, how do you set that model in your Microsoft Excel or the software as well. At Risk and Crystal Ball, both of them installs in your as a adds in your Microsoft Excel. So just make sure you do have the Microsoft Excel installed before you install those two softwares. So depending upon your model, you just set up your variables with the distribution, and you set up your final. Okay, Jacobo is asking, please, in the situation where you have one value as the available experimental result, how can we generate the random values around this value for simulation? You need to look on how that value is being generated. Based on the input of those model, you will generate the distribution of your output, which will be your one single value. Folks, are there any more questions for me? It seems like you don't have any more questions, so I will let you go, and I will upload this lecture along with some practice questions in Crystal Ball as well. Just go through them and just drop an email if you have any questions for me. Okay, thank you very much, and have a good weekend. See you on next Tuesday. Thank you, everyone.